Yeah, you can speak. Like, how was your contest? Like, how many problems you were able to do? Okay, nice. Still, anyone else who wants to respond? How many of you did the first question? Can I know? Okay, okay. Now let's go through the first question. Like here, the question is: Little Rose has a phone with desktop. The desktop consists of several screens. Each screen is represented as grid of size 5 by 3, which means 5 rows and 3 columns. There are X applications with an icon size of 1 by 1 cell. Such an icon occupies only one cell of the screen. There are also Y applications with an icon size of 2 by 2 cells. Means one icon size of 1 by 1 cell and another Y applications with an icon size of 2 by 2 cells. Like screen size is 5 by 3 cells. Then we need to find the Rosie wants to place the application icons on the minimum number of screens. This is our task. So now we have total 15 cells, means 5 rows and 3 columns. We have total 15 cells, and we have two types of icons, uh, which is like 1 by 1 and then 2 by 2. So, and anyone respond that maximum how many 2 by 2 cells are possible in this screen? Yeah, you're right. So maximum 2 by 2 cells are like 1, 2, and remaining we have 1, 2, 3, 4, 5, 6, 7. So 1 by 1 cells is 7, and then maximum 2 by 2 cells are 2. So now that is our question. Here we are given with some test cases where first one represent the number of X applications and then Y applications. If X is 0 and Y is 0, what is the answer? Our output is 0, right? And what if Y is 1? Means if there is a 1 2 by 2 cell. If there is 1 2 by 2 cell, then we are left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if Y is equals to 1, that means 1 2 by 2 cell, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 1 by 1 cells possible. So now at max Y is equals to 2. For one screen at max there will be 2 by 2 cells, and remaining 1 by 1 cells will be like 7. So now we need to find the minimum number of screens needed for the given x and y values. This is our task. Can anyone tell the approach? Yeah, you can speak. You can speak. Yeah, okay. Then, yeah, this is right. Still, anyone else? Hmm. So now let's see. If x equals to 0 and y equal to 0, simply we'll return our answer as 0. And suppose if x and y are not 0. Suppose if x is not 0, uh, y not equals to 0, then first we'll calculate how many 2 by 2 cells are possible. So then we'll calculate the left of the number of cells. Like how many 2 by 2 cells will be there. Suppose if I consider one test case like 17 comma 3. Here the x value is 17 and y value is 3. Suppose if I consider this test case, here there will be 3 2 by 2 cells. So for 3 2 by 2 cells, definitely we need two screens, because for one screen there will be two 2 by 2 cells. So how we'll calculate this? Simply 3 by 2. Two 2 by 2 cells per screen. Now there are three 2 by 2 cells. So we are calculating how many number of screens are required. So simply it's like 3 by 2. And next we'll consider this 17. So in this 17, now we have two screens. So for every screen there will be 15 cells. So now for two screens, total 30. From this 30, we'll subtract the 3 2 by 2 cells. 3 into 4, 12. So now we are left with 18. So now still we have 18 1 by 1 cells. But our given x value is 17. So simply we can fill up these 1 by 1 cells in these two screens. So we'll return the answer as 2. Suppose if the x value is 19, then what we'll do? Now our left out 1 by 1 cells are 18. Our x value is 19. So 19 is greater than or equals to 18, greater than 18. So now what we'll do, simply we'll subtract this 19 minus 18. So still we need one more 1 by 1 cell. So we'll take that 1 by 1 cell from the next screen. So here we'll be requiring total 3 if x value is 19. If x value is 17, then the answer will be 2. If x value is 19, then our answer will be 3. Is this clear for everyone? Some you can respond something. Okay, now let's see the code. So for each test case, we need to take the x and y values. Simply we'll take the input. Oh, sorry. So next what we need to do, if x and y both are 0, then we'll print our value as 0. In else case, like if y not equals to 0, then first we'll calculate how many number of screens required for the 2 by 2 cells. So simply I'll take one variable k. So y by 2.0. Sorry, continue. Now I'm left with, so total there are k into 15. For each screen there are 15 cells. So k into 15 minus, already I have filled y 2 by 2 cells, right? So y into 2 by 2, so 4, y into 4. And now I'm left with these many cells. So simply my x value is x minus left. Now if x is greater than 0, x by 15.0. So what I'm doing here, first I'm calculating how many number of screens needed for the given y value, and I'm calculating the remaining number of cells present in the screen after filling up the 2 by 2 cells. And if x is greater than 0, simply I'm adding this value to the k, and then if suppose in else case, like if y not equals to 0, simply is this code clear for everyone? I'll just take the test cases. So 1 minute. Okay, so random mistake. H. Okay, is this clear? Hello, is this clear for everyone? First question. Okay, let's move to second question. Here, Polycarp has, first of all, how many of you did the second question? Solanki, Surya Haldar, any one of you did the second question? Okay, you can tell the approach or else raise something you can respond. Okay, okay, let's see the second question. Polycarp has a string S which consists of lowercase Latin letters. He encodes this string using the following algorithm. First, he constructs a new auxiliary string R which consists of all distinct letters of the string S written in alphabetical order. Then the encoding happens as follows. Each character in the string S is replaced by its symmetric character from the string or character of the string or will be replaced by the last, the second by the second from the end, and so on. Means suppose, for example, if string S is Codeforces, then string R is obtained as CDEFORS. So first, they have given the string S. So first we need to arrange the given string. I mean, we need to arrange the characters in the string in alphabetical order. So we'll remove the repeated ones and then here C, D, E, F, O, or S. We have ordered in the alphabetical way. So now we need to swap the first one and the last one, second from the first and second last. So we need to swap in this. We can have a swaps in this way. So now for the given question, so here the SEROFEDSOC. What we need to do is, so okay, we'll take this example. SER. Okay. So this is our example. So first what we need to do is we need to arrange them in the alphabetical order. So here C and then D, E, F, O, R, S. So now this is our string formed by the given string. So now we can have swaps between C and S, D and R, E and O, F in this way. So now what we should return our output. So as S can have swap with C. So in S is swapped with C. Next E can have swap with O. So next E is swapped with O. Next R. R can have swap with D. So we replaced it with D. So in this way we should return our answer. So anyone tell the approach like how to write the code? First we'll take the string and we'll store in another string. We'll sort it and then we'll add that into set. So that we'll take one set so that it won't take the repetitive elements. We'll be having the unique elements. After that, we can have swap between like first one, last one, first and from the last second. We can have swaps, right? So later we need to do that. So let's do. First we need to take the length of the string. Then string. Then I'm temporarily storing this string as in T. Now I'll sort the string. Then we can do it in like two ways. Like we can take the set and we can insert the elements, or else there'll be one function like t dot erase. If someone don't know, like you can do it in that way also, like taking set and then inserting the elements, so that we'll be having the unique, or else we can use this function also, t dot erase unique of t dot begin to so what this function will do is like first it will arrange, suppose if there is a string like a b b a, so first this unique t dot begin to tn will arrange that a b b a into a b a b, and then the pointer will be pointing to second a. From that it will getting erased, so we'll be having only one ab instead of having ab ab, we'll be having ab, one ab will get erased. So this is the use of that function. And then okay, we'll store the size. Now I'm taking one more string where I'll store my answer. Now I need to do the, I mean, after swapping, I need to replace the swapped ones, right? So for that, I'm running the loop int I is equals to 0. From there to t dot size. So n2, n1, n1. So now I'm doing is like first I'm taking the string, I'm running the loop in the given string, like we took the test case, right? SEDR. So I'm running loop for it. If I find the first character in my t, now I'm subtracting the -1 minus index, so I'll get the last one. So t in string t, if I find the first character of that string s, then I'm storing that index into this variable index. Now what I'll do is I'll add my answer n2 minus 1 minus index. That's it. Now I'm returning my answer. Simply I will take this. So yeah, we got it. For this Codeforces FFT algorithm W, and then so in this way we can do, or else we can take the set and we can do it. We can do it in two ways, or else some other method also. Is this clear for everyone? Okay, remaining Surya Haldar, Sauna Ghosh. Okay, okay.
Your first was brute force that did TLA. So after that, thought that we can make a map where the first index will be a question mark, and then next two index, and then another map where second index will be question mark, and another where third index will be question mark. If we think in that approach, but could not do it. Means anything could be at that position, but like index 0, index 1, index 2. If index 0 is question mark, so any integer can be at index 0, but index 1 and index 2 same integers will be there. Yes, bhaiya. uh, Bhaiya, first with brute force, that was the O of n square, but in map I think so it can be reduced to big O of n, but this one I could not complete.
Is my screen visible to?
Yeah, your screen is visible.
Acha, so let
But yeah, for two pairs, A, B, and C, three are only equal. No, bhaiya.